My dear friends, this is Sridhar Patnaik. Today we are going to learn group theory, third semester in degree second year, I think, groups. Today we are going to learn some preliminary concepts in groups, which is very useful in mathematics. Group theory. In group theory, we should learn some definitions. These definitions are very important. These are very most important definitions. In this theory subject, we must learn the subject. We must learn the subject. First of all, binary operation. Definition of binary operation. If G is a non-empty set, if G is any non-empty set, then any function mapping from G cross to G is called binary operation. Binary operation. If G is a non-empty set, then any function mapping from G cross to G is called binary operation. G cross to G means Cartesian product. This is A comma B, such that A comma B belongs to G. A comma B belongs to G. For example, this is G cross to G. This is set G. In this we have ordered pairs AB like this. I suppose that F is a mapping from this should be mapped to G. This should be mapped to G. Then we say that F is binary operation on G. F is binary operation on G. That means F of G cross to G must be in G. Now this is GFG belongs to G. GF to G belongs to G. Here in this chapter, the functions in general, that means AB, ordered pair AB belongs to G. F of AB belongs to G. AFB belongs to G. Then we say that F is binary operation on G. In this chapter, in general, binary operations are denoted by star, circle under plus, in some other notations also. We have a algebraic okay. For example, I would like to define a function. For example, this is the set of natural numbers 1, 2, 3, 4, etc. N cross to N is a set AB. Is set ordered pair. In this we have ordered pairs AB. I denote a function. It is denoted by circle. This is N. This must be in N. That means we have to define a function on N cross N such that A circle B defined by A plus B plus 2. This is I define like this. A comma B belongs to N. We know that A plus B belongs to N. 2 comma A plus B belongs to N. This implies A plus B plus 2 belongs to N. This means A circle B belongs to N. In this case, we say that circle is binary operation circle is binary operation on n. Circle is binary operation on n. Circle is binary operation on n. Okay? Example, star is defined on. Star is a function defined on n such that a star b is equal ab by 2. ab by 2. Whether now star is binary operation on n or not, we shall discuss. What is happening. A comma b, where a comma b belongs to n. A comma b belongs to n implies ab belongs to n, no doubt. ab belongs to n. But ab belongs to n, 2 belongs to n, but a by 2 is need not be belongs to n. A by 2 is need not be belongs to n. That means a star b does not belongs to n. Therefore star is not binary operation on n. So many students does not understand what is the relation to this and the definition. Here n star n, this is n star n set, this is n star n, this is n. Star is a option, star is a function defined by such that star of n cross n must be belongs to n. Here a star b, it does not belongs to n. A star b does not belongs to n. That's why star is not a binary operation on n. For example, define a function. Define a function or mapping. Define a function circle under class on z. Z means the ring of integers. The ring of integers. Z is equal to negative and positive, 0, 1, 2, 3, etc. This is the set, the ring of integers. Define a mapping circle under plus on z such that a circle under plus b is equal to a plus b minus ab. A plus b minus ab. Now we shall discuss whether the circle under plus is binary operation on z or not. Let us once clarify. So we know where a comma b belongs to z implies a plus b comma ab both are belongs to z. The subtraction a plus b minus ab also belongs to z. Therefore a circle under plus b belongs to z. Therefore circle under plus is binary operation on z. Now I am going to give another example. Let us define a mapping. Circle on q plus. Q plus means the set of all positive rational numbers such that define a mapping circle on q plus. Such that a circle b is equal to ab by 3. Whether now a circle is a binary operation on q plus or not, let us discuss. Q plus means the set of all positive rational numbers. Here a comma b belongs to q plus ఇక్కడైనా పెట్టచ్చు. Q plus, this means AB belongs to Q plus, AB belongs to Q plus, AB belongs to Q plus, 3 belongs to Q plus. This implies AB by 3 belongs to Q plus. This implies A circle B belongs to Q plus. Therefore, circle is binary operation on Q plus. Circle is binary operation on Q plus. This is very most important definition in group theory. One of the most important, this is primary definition. We have algebraic operations plus, minus, into, divided by. These are called algebraic operations in algebra. Whether these are binary operations or not, we will let us confirm once. Operation set natural numbers. A comma B belongs to n implies A plus B belongs to n. So that plus is binary operation on n. A comma B belongs to n. A minus B does not belongs to n. Subtraction is not binary operation on n. Similarly, A comma B belongs to n. AB belongs to n. We know that. So multiplication is binary operation on n. Similarly, division. A comma B belongs to n. A comma B belongs to n. A by B does not belongs to n. A by B does not belongs to n. So that only in algebraic operations, plus and multiplication, these two only are binary operations on n. These two only binary operations on n. Let us check another. Check for another. W, same. W is also whole numbers. This is the set of whole numbers. Friends, there is only one difference to the set of natural numbers and zero. Set of natural numbers and whole numbers. The only one difference, 0 is excess element in this set. Here also, A comma B belongs to W implies A plus B belongs to W. So that plus is addition is binary operation. Addition is binary operation on W. Similarly, minus, subtraction. A comma B belongs to W implies A minus B does not belongs to W. So that minus subtraction is not binary operation on W. Similarly, into, multi belongs to W, AB belongs to W. So that multiplication is binary operation on W. Similarly, divided by. A comma B belongs to W. A by B does not belongs to W. So that W is not binary operation on W. Okay, friends. Now we are going to find on set of integers. Z is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. 1, 2, 3, etc. దీన్ని ఎట్లా రాయొచ్చు? Z minus union singleton 0 union Z plus అని. The set Z can be expressed union of negative integers union singleton 0 Z plus. Okay, now I am going to discuss whether addition is binary operation on Z or not. For example, A comma B belongs to Z implies A plus B belongs to Z. Clearly we can say that addition is binary operation on Z. Okay, friends. Next, I am going to discuss about subtraction. If A comma B belongs to Z, A minus B belongs to Z. A minus B belongs to Z. So that subtraction is binary operation. Subtraction is binary operation on Z. Similarly, multiplication. If A comma B belongs to Z, we know that AB belongs to Z. Therefore, multiplication is binary operation on Z. So that multiplication is binary operation on Z. What is going to be about division? Here, A comma B belongs to Z. A divided by A by B need not belongs to Z. It not belongs to Z. Therefore, the division is not binary operation on Z. Now, let us going to discuss about the set of all integers. We know that x such that x is equal to p by q, p comma q belongs to Z, GCD of p comma q is equal to 1 and q not equal to 0. Q not equal to 0. This is the set of all integers. Whether these operations are binary operations on Q or not, let us discuss. We know that A comma B belongs to Q implies A plus B belongs to Q. No doubt about it. Therefore, addition is binary operation. Addition is binary operation on Q. Similarly, A comma B belongs to Q implies A minus B belongs to Q. Therefore, subtraction is binary operation on Q. Similarly, A comma B belongs to Q implies AB belongs to Q. Therefore, multiplication is also binary operation on Q. In case here A comma B belongs to Q. A comma B belongs to Q implies A by B belongs to Q if whenever B is not equal to 0. If B is not equal to 0, here division we must follow the special case. B must be not equal to 0. Then A by B also belongs to Q. In this case, division is also binary operation on Q. In case divided by is if divided by wanted to be binary operation on Q, the Q is must Q minus singleton 0. Q minus singleton 0. On this set, this operator is binary operation. Now we are going to discuss about the set of all real numbers. There is no doubt about it. The same concept belongs to Q. Plus is binary operation on R, minus is binary operation on R. Multiplication is also binary operation on R. Division except B not equal to 0. The same case will apply to the set of all real numbers. These are the common. These concept is minimum concept. Now I am going to discuss another definition. Algebraic structure. Algebraic structure. A non-empty set equipped with one or more binary operations. then we say that one or more binary operations. One or a non-empty set equipped with one or more binary operations is called algebraic structure. If G is a non-empty set, circle is binary operation on G, then G circle is said to be algebraic structure on G, not on G. G, a non-empty set equipped with one or more binary operations is called an algebraic structure. If on any non-empty set, if there is any binary operation defined on that, then the structure G circle, like this, G circle is said to be a algebraic structure. G circle is, for example, the operation circle is defined on Z such that A circle B is equal to A plus B minus AB. A plus B minus AB. Now in the previous we learned this example also. A circle is binary operation on Z. Circle is binary operation on Z. Therefore, Z circle is an algebraic structure. Z circle is an algebraic structure. Z circle is an algebraic structure. Okay. So I am going to give another example. M is the set of all 2 by 2 matrices defined on R. M is the set of all 2 by 2 matrices defined on R, like this: A, B, C, D, where A, B, C, D belongs to R. Now, addition of matrices. A comma B belongs to M. Implies A plus B also belongs to M. For example, A is equal to A1, B1, C1, D1. B is equal to A2, B2, C2, D2. Now add this to A plus B, A1 plus A2, B1 plus B2, C1 plus C2, D1 plus D2. Here A1 plus A2, this belongs to M. Therefore, because A1 plus A2 belongs to R, B1 plus B2 belongs to R, C1 plus C2 belongs to R, D1 plus D2 belongs to R. Hence, this matrix also belongs to M. Therefore, plus is binary operation on M. Plus is binary operation on M. Therefore, M plus is an algebraic structure. Similarly, multiplication of matrices is also an algebraic structure. In this way, AB, multiplication of matrices, AB is also belongs to M. Therefore, M cross is also known as algebraic structure. Algebraic structure means a non-empty set equipped with one or more binary operations. We learned in the previous N plus is an algebraic structure, Z plus is an algebraic structure, Q plus is an algebraic structure, R plus is an algebraic structure. Similarly, N into is an algebraic structure, Z into is an algebraic structure, Q into is an algebraic structure, R into is an algebraic structure. In this way, if we follow, so many examples we can give. So that this is the brief concept about the algebraic structure. Okay friends, tomorrow we will discuss the further concept. For more videos, if you like my class, please subscribe my videos. Thank you.